Alright, so what we're going to be looking at on Monday has to do with quadratic inequalities. So what I want to do in our notes to start with is just review what inequalities are and some basic solving that we did back in Math 1 and Math 3. So first off, here's your four symbols. We have the less than, we have the greater than, less than or equal to, and greater than or equal to. And then with each of these comes a specific notation. So when it comes to doing the graphs on the number line, less than gave us an open circle and greater than gave us an open circle. Less than or equal to gave us closed. Greater than or equal to also gave us a closed. Now when it came to interval notation, so that's when we wrote from like -2 to 2, or we'll go over that later, but the less than, if there was no equal, we used parentheses. Greater than, again parentheses because it's not equal to. But when it was equal, we used our brackets to show that things were equal, whether it be at the beginning or at the end. So what we're going to be looking at specifically is solving and then writing our graphing and writing in interval notation our solution. So here I have two examples. We'll do two more before we call it a night, and then we'll do some more in class on Monday. Sorry. So if we look at this first one, 3 is less than x plus 2, which is less than 7. So we got to solve it, graph it, and write our answer in interval notation. So I can subtract 2 from all three sides, and we get 1 is less than x, which is less than 5. So when we graph it on a number line, we got to graph 1, 5. Our circles are going to be open because they're both less than. And we're looking to be where x is between 1 and 5. And so when we do our graphs, don't just draw it right over the number line. That makes it really hard to tell. Bring it up off the graph a little bit so we can see exactly where the shading is happening. So your graph would look something like this. Your x is between 1 and 5, but not equal to 1 or 5. And then for interval notation, we would use parentheses that our interval for our solution is between 1 and 5. Number 2 here is a different kind of compound inequality. This one's an or statement. And so we're going to have to solve both inequalities, but we'll graph them on the same graph. So I'm going to subtract 4, x is greater than 12, or we'll add 1, and then divide by 2, x is less than 4. So again, we have 12, we have 4, and so let's see, we have open circles, but we have bigger than 12, so that's this way, and we have less than 4, that's this way. In an or statement, it's okay that they go away from each other because we're looking for one set or the other, not both. Whereas in number 1, that's an and statement, meaning we had to look for where both inequalities were true, and that would mean where they overlap. So because it's an or statement, we have a graph like this, which is perfectly okay. So when we do our interval notation, we'll have from -infinity to 4, again in parentheses, in union with 12 to infinity. So here we have our union symbol that will combine our two intervals or tell us that both of them could work for a solution. Okay, example number 3. X is greater than or equal to -5, or x is greater than 7. So this one, there's no solving really. We're just going to look at the graph and really try to understand what or means. So when we graph this on our number line, we have -5, we have 0 somewhere in the middle, and 7. So just as a real quick note, I'm not one who requires that 0 is on the graph, but if it's somewhere between your numbers, go ahead and put it. So like on number 1, how 0 was really close, I went ahead and added it just as a reference point. Here it was a little too far, and I didn't want to have to extend my graph just to include 0. So since here 0 is between my two endpoints, I'm going to go ahead and add it to it. So we have greater than or equal to, so solid circle, that's this way. Open circle, greater than. So again, because it's an or statement, it either needs to be in this interval or this one. But one of the nice things here, or things that we notice, is that this interval, x greater than 7, is part of the interval x is greater than -5. So this whole statement that we were given can be summarized down to just x is greater than -5, because anything that's greater than 5 is going to work in either of these because of that or statement. So for interval notation, we'll have a closed bracket, because it's of the equal, -5 to infinity with a parenthesis. Okay, last one for tonight. And this is how do we solve a compound. So this is an AND statement because it's all compiled into one. But the problem with the difference between 1 and 4 is that all 3 parts have a letter. So on the first one, we were able to just isolate x in the middle. It's not so easy on this one because whatever we do, we have to do it to all 3 if we're going to keep it in that format. So when you have something like this where you have x in all 3, it's a lot easier to separate them. So I know that my first inequality, so I'm going to separate it so it looks like number 2. 3x minus 1 is less than or equal to 2x plus 1. Then I have my second inequality, which is this middle one, and the last one together. 2x plus 1 is less than or equal to 3x plus 4. So we're going to solve each of these, and then we'll put them back together at the end. So here, and then so also if you want, you can write the word AND, because this is an AND statement because it was a condensed format. So I'm going to subtract 2x to get my x's together and add 1. So I have x is less than or equal to 2. Over here, again, I'm going to subtract 2x to both sides to get my x's together and subtract 4. So I have -3 is less than or equal to x. Again with the word AND. So we can go to graph it. -3, 0, 2. Closed circle, less than. For this one, we have a closed circle as well. And you want to read it with the variable first. So x is greater than -3. If it helps to rewrite it so that the x is first, you can do that. So just make sure that since the open end is next to the x, that when you rewrite it, the open end is next to x. So x is greater than or equal to -3, so that's this way. The AND means we're looking for just where they overlap. So our answer would be between -3 and 2. So again, they're both equal, so -3 and 2, and we would use our brackets. So this should have all just been a review of the types of inequalities you've done before. When we get into class, we're going to look at how we do the same thing, but with quadratic equations. So what do we do when it's not so simple and linear? What do we do when it becomes a quadratic? So I have two more examples that I want to do that are quadratic, but we're going to save those for in class to make sure you guys all get it. So if you have questions on the review ones, 1 through 4, please come with questions, and then we'll also do the quadratics in class together.